Today we're gonna learn introduction to super logarithms. Super logarithms is the inverse of tetration. Okay, so it should look like this: so log and s before the log. So log base 2 is 65,536 equals what? I'm gonna compare that to logarithms. Okay, log base 2 is 65,536. I'm gonna do the logarithm first. So I'm gonna do it with the calculator, okay? I'm gonna do it with the calculator. Okay, so let's go do log. Hold on. Log. Where's the log base? Never mind. Log base 2 oh 65,536. It equals 16. Okay? So wonder why? 2 10 raised to the 4 equals 2 raised to the 2 raised to the 2 raised to the 2. And then 2 squared is 4. And then 2 raised to the 4th power is 16. Yep, that's the answer, 16. But 2 10 raised to the 4 equals 65,536. We did that in our previous videos. Okay? So the answer is 4. It's just find the missing power tower. Convert that to tetration form. 2 10 raised to 4 equals what inside? Okay? To convert logarithms to exponential form, same thing over here. 2 raised to the 16th power, but it's exponents, equals 65,536. So I'm going to draw a line over here for each. Okay? So 2 10 raised to 4 equals 65,536. That's the answer if you convert it. Now, for this one, 2 raised to the 16th power equals 65,536. Those are the answers if you convert it. Okay, now we're gonna do some equations. Let's go evaluate. Let's go evaluate first. Log base 2 of 16. So I know what is 2 10 raised to 2 equals 4, right? But 2 10 raised to 3 equals 2 squared, which equals, you gotta evaluate it from up to down. 2 squared is 4. 2 raised to the 4th power equals 16. So that means the missing one is 3. Again, if you convert it to tetration form, 2 10 raised to 3 equals 16. Let's go do another one. Log base 4 of 256 equals what? So 4 10 raised to 2 equals 4 raised to the 4. 2 times. Remember, it's 2 times because the power tower says 2, which equals 256. Okay? So the missing one is 2. Again, 4 10 raised to 2 equals 256. Okay, now we're going to get on to some Tetration equations. 2 Teterated to x equals 16. I don't want to exponentiate both sides, neither taking the square root of both sides, neither taking the logarithm of both sides, because the inverse of Tetration is super logarithms. So let's go take the super logarithm of both sides. Let's go take log base 2 both sides. Now the 2's cancel, giving us x equals log base 2 of 16. Now 2 teterated to what gives us 16? 2 teterated to 3 gives us 16. So that means x is 3. When I plug in 3, 2 teterated to 3 equals 16. That's true, because 2 squared equals 2 raised to the 4th, which equals 16. Now, let's go do 2 teterated to x equals 65,536. Now I gotta take the log base 2's of both sides. The 2's will cancel, giving us x by itself, giving us log base 2 of 65,536. Again, 2 teterated to 4 equals 65,536. Okay, let's go do log base 4 of 256. Do those equations equals, hold on. It should have been 2 teterated, again, 4 teterated to x, 4 teterated to x equals 256. And then 3 teterated to x equals 27. Okay? So we're gonna take the log base 4 of both sides. Log base 4 of both sides. And then the 4's are cancelled, giving us x equals log base 4 of 256, which equals 2. 4 raised to the 4th power equals 256. Now, 3 teterated to x equals 27. So let's go log base 3 of both sides. Let's go do that. Giving us x by itself, log base 3 of 27 is 2, because 3 teterated to 2 equals 3 cubed, which is 27. Bye, guys. See you in the next video.